This lesson covers Chapter 3, Section 8, the Pythagorean Theorem. So let's see where this theorem comes about. So I have a picture of a triangle drawn here, and what we're going to end up looking at when we're looking at our triangle is whether it's a right triangle or not. And this little symbol right here symbolizes that it's a 90-degree angle, so it's a right triangle, so we can use Pythagorean's theorem. So Pythagorean's theorem says if we take two of the legs, we call the legs the two sides connected by the right angle symbol here, and we call one of them A and B, the other one B. Then if we square A and add it to the square of B, it equals the hypotenuse squared, which is side C. Hypotenuse is always opposite the right angle. So here's how the formula works. The A squared means that if you make a square out of this side, so if I take this A and I square it, basically squaring something gives us an area of a square. So that means that this side's A, we know that this side over here is A times A makes A squared. So this area is A squared. Well, if I take a look at the other side, I'll call this one B, and if I make a square out of it, so pretending that's a square, I don't want to go too far down or else I interfere with that problem there, but if I say that this side's B and this side's B, the area of this square is B squared. So basically you're taking this area here and adding it to the area here, and what we end up getting is the area of this side here. So if I make a square out of it, again, I ran out of room, so it looks more like a rectangle than a square, but if this side is C, this side is C, the area of this square is C squared. C times C makes C squared. So basically the formula is saying the area of this square plus the area of this square is going to equal the area of the hypotenuse squared. And so we're going to use that formula to solve these problems. Let's take a look at it. So what they say to do is find the missing side, approximate the square roots to a approximate square roots of non-perfect squares to the nearest tenth. And so it's just going to be an estimate. So we're just going to go about to the nearest tenth. We'll do our best job. So the side opposite the right angle is always your C value. So we're going to take our numbers and put them into this formula. And so we go ahead and do that. I've got 6 squared plus 12 squared equals C squared. So I now need to just square those sides, and 36 is what we get when we square 6. 144 is what 12 squared is, and it should equal C squared. Well, the common mistake is people will end up adding these numbers together, and they'll do a good job doing that. They'll get 180, and they'll say, oh, there's the answer, there's C. That's not what C is, that's C squared. So that means that's the area of this square for the hypotenuse. If we made a square out of that hypotenuse, that side squared, that's what we'd get. So the way we find out what C is we take the square root. The square root finds the two numbers that multiply to make 180. But 180 is not a perfect square, so what they said to do is just estimate. So let's take a look at the perfect squares that are near 180. 169 is 13, and 196 is 14. Well, 180 is in between these. It's almost right in the middle, a little closer to 13, but pretty close to both of these values. And so what we'll end up saying is that the square root of 180 is maybe about 13.5 or 13.4. That's a pretty good approximation. But I know it's somewhere right around that area. And then just make sure we put the units there of inches. So on this one's a little different because they look at the opposite the right angle. They're giving us the C value this time. So we're looking for either the A or the B value. It doesn't matter which one. I'm going to call it the B value this time. So what we've got is A squared plus B squared equals C squared. That's our formula. And we substitute the numbers in. And I've got 21 squared plus B squared equals 29 squared. So I have to square these numbers. And when I square the 21, I get 441. Plus B squared equals, and then when I square the 29, I get 841. And so when I go ahead and subtract that 441 from both sides, let's take a look at what we're getting. So we've got now B squared equals 400. Well, that's the square. That's the area of the square if I was to make a square out of this side. But I want to find just one of the sides. So what that means I need to do is take the square root of both sides. And so when I do that, I'm left with exactly 20. So 20 centimeters is the answer. Well, looking at this one, same sort of thing. Again, look at the right angle. Go opposite the right angle gives us our C value. So the other two sides are going to be A and B. It doesn't matter which one you call A or which one you call B. Just substitute the numbers in the formula. 12 squared plus b squared equals 18 squared. And so we go ahead and square some of these numbers. And so we end up with 144 plus b squared equals 324. So we're ready to do some subtraction. So I'll take away the 144 from both sides. And when I do that, I'm left with b squared equals, and then I got to borrow a little bit here, and that leaves me with 180. Well, I've seen that number before. That was on the first problem. And so when we take the square root, we automatically already know, since we've done this once before, that 180 is going to be pretty close to 13, and it's kind of in the middle between 13 and 14. So we're saying, oh, just about 13.5 inches is a pretty good approximation. Now, it could get a little bit closer, and if I pull up the calculator here, see if we go ahead and do 180, and take the square root, it's going to be a little bit closer to 13 than it is to 14, because you saw how when I went ahead and looked at those numbers, and I've got the example over here, when I looked at these numbers, you see 180 is only 11 off from 169 when it's 14 off from 196. So 13.4 would have been a better approximation. And so you can just kind of go with what you think is pretty close, because that's what we're doing when we're using these values. So 13.4 inches would have been a fine answer, or 13.5. I'd take either one. So let's take a look at the next few problems. And here we've got a 3 points, and that are making a right angle, obviously, and they're connected together to make a triangle. And so we've got a right angle right in this corner here. And what we want to do is find the length of this side right here. Well, I can count the spaces for these sides. So you see how this is 1, 2, 3, 4, 5, 6. So this side is 6 units, and this side is 1, 2, 3, so 3 units. And so I need to find the side opposite the right angle, so that's my c value. So I'm going to set up it up in Pythagorean Theorem. So 3 squared plus 6 squared equals c squared. So we do some work there. 9 plus 36. And when I add those two numbers together, I end up with 45. And this all equals c squared. So when I go ahead and take the square root of both sides, notice how the square root of c squared is c. And I'm coming up with an approximate value. So sometimes we use these squiggly lines for an equals sign when we're talking about approximates. And 45, if we look at 45, the square root of that, 36 is 6, but 49 is 7. So you see how much closer 45 is to 49 than to 36. So a good approximation, I would say, would be somewhere around the neighborhood of 6.8 or so. So if you said 6.5, that's a good number, but let's just check and see what the calculator ends up saying. So just to see what we've got, if I go ahead and clear this, and I press in 45 and the square root button, you see 6.7 would have even been a better approximation. So again, all we're doing is just estimating what that is, pretty close to it. So if you said 6.8, that's fine. If you said 6.5, I'm good with that, or 6.7, any of those answers would be fine. Just put units for the units on this one, since they don't give us exact units here. And on this next problem, we've got an interesting scenario here, because we're trying to find the diagonal of this line here. So let's take a look at it. So as we look at this problem, we're trying to find the length of y. But the thing about this is that in order to do this, there's a right triangle here, but I don't know what this length is here. So actually there's two parts to this problem. I've got to first find out what this length of the side, this length of this triangle is. So I'm going to call that x. And when I look at x, it's opposite of this right angle right here. So there's a right angle right there, and opposite of that is x. So this side is the side I need. But this is not 2. This side is parallel to this one over here. So this side is going to end up being 3 inches, and this side is 6 inches. So to find out what x is, I'm going to have to do 3 squared plus 6 squared. And that's going to end up equaling my x squared. So we've actually done this one before. This was the same as this problem. So I see that this is 9 plus 36, and I end up with x squared. And so I go ahead and do that work. 45 is what I get. And we saw before that a better approximation of this number was 6.7. So I'm going to use that this time. Again, and the reason I'm using the better approximation this time is that I want to find out what y is, and I'll get a better approximation when I do that, when I go ahead and come up with this value. So I'm going to use 6.7 inches. That's just an approximate now, but that's what x is, and the side going vertical is 2 inches. So this side's 2 inches, and that's what I need, because I'm trying to find opposite this right angle here, which gives me that diagonal. So now I'm going to do 2 squared plus 6.7 squared, and this is going to equal y squared. So when I go ahead and do that, I get 4. Now, when I square the 6.7, so I have to do 6.7 times by 6.7. So 6.7, and I don't see a square button. I could use this one right here, but went ahead and multiplied already, so I'll just go ahead and do that. 44.89. This is what I get. So 4 plus 44.89. And this equals y squared. So I add these two numbers together, and notice what I get. I get 48.89. That's really close to 49, which would be exactly 7. So we're going to go ahead and we're going to call this pretty close to 7 inches. It's just a touch under 7 inches, but it's pretty close to 7 inches there. Now, if I was supposed to fit something in there, I wouldn't pick 7 inches. I'd probably pick like 6.9 inches to make sure it ends up fitting. But it's going to be really close to 7 inches. So the last problem here talks about an ant walks 6 inches east. So we need to know which direction is east. Well, north-south, west is to the left, and east is to the right. And so it's walking 6 inches east. So there's 6 inches east. And then it walks 4 inches north. So there's 4 inches north. And they want to find out what is the distance to the nearest tenth from where it started here to where it finished here. So that means I need to find this distance right between these two lines. So I'm going to use Pythagorean Theorem because there's a right angle, and that's opposite, so that's our c value. So it's 6 squared plus 4 squared equals c squared. So 36 plus 16 gives me c squared, and when I add those two numbers together, I end up with 52. And when I go ahead and take the square root of both sides, it gives me about 7.2, I'd say. Because again, 49 is going to be 7, and 64 is going to end up being 8. So 52 is pretty close to 7, closer to 7 than 8. So that's why I went with 7 or 7.2 inches. And so those are the types of problems that you're going to end up seeing on tonight's homework. Good luck.